Good morning, good afternoon, good evening, everyone. Welcome to our webinar from the community of Oceania Geospatial Water Resource Workgroup. And today we will be talking about water monitoring and especially groundwater. And so if you could please introduce yourself in the chat, your name, your role, and your country, so everybody knows where you're from and what your job is. It will be easier for everybody. I'm Pearl Winchester. I'm originally from New Caledonia, and I'm a tropical island water specialist. I'm an IT engineer working in GIS and public policy, as I've been working 14 years for the government of New Caledonia. And right now I'm in France, and I founded Smart Ecosphere, that is a company just by myself. And Nicolas, if you could please introduce yourself.
Sure thing, Pearl. Yes, it's Nick. I'm also coming from a hydrology background, but currently working more on remote sensing and Earth observations applications, and currently working with SPC and supporting these hydrology webinars. Thank you.
Thank you, Nick. And now I'm just going to give a few minutes to our great speakers for today that I thank to be with us today. So we have Dr. Ashnil Sharan, that is in Australia, and we have Dr. Kathy Koloa, that is in Papua New Guinea. If you could please introduce yourself. Ashnil first, maybe.
Hi, good morning all. My name is Ashnil and I'm currently based in Townsville, Australia. I've completed my PhD in water resource engineering and now working for Tenant Mines in Northern Territory as an hydrogeologist and environmental advisor.
Thank you, Ashnil. Kathy?
Hi, everyone. I'm Kathy Koloa from Papua New Guinea. I'm with the University of Technology in Lae. And I'm started as a lecturer in 2019, and this would be my 6th year in the GIS and GIS section with the School of Surveying and Land Studies. Thank you.
Thank you for being with us today. All right. Just as we have some new people again today, and I'm very happy that we have some new faces even if we don't see you yet. Just so you know, the community of Oceania Geospatial Water Resource Workgroup, our aim is to share information and knowledge for the benefit of our Pacific Island countries and territories in the geospatial field, and especially in water resource. And we have been talking about all these topics here, especially rainfall, flash floods, drought, surface water. We are talking about groundwater today, and this list is definitely not exhaustive. I will say it again at the end of the webinar, but for example, our next webinar that is already scheduled in October will be about wastewater and reuse. So everyone is welcome. It's public and private sector alike, and you can join us on our LinkedIn group. I will put the link in the chat just after. And so I wanted, before to give the floor to Ashnil, I wanted to just give you a few links to some reports that I found doing a quick review. And especially I wanted to show you this map that is coming from the Pacific Island Groundwater and Future Climates study that is from 2014. I didn't find any newer, so we still have a lot of work to do around groundwater in the Pacific Islands. This is a good news for us working in the field. And so this map, I found it interesting because it's showing the potential impact of the rainfall in 2015 2050, sorry, on the groundwater availability. So what we can see is actually that many of our islands in red will we be facing groundwater lack in the coming years. So we do have to work on our groundwater reservoir to make sure that we still have some water to drink and to survive in 2050. So the same, I'm going to share these links in the chat right after. Nicolas, is there anything else you would like to say on the subject?
I think that maybe after the presentations, it might be good just to hear briefly from Anesh, if possible, just because they've done a lot of work on the atoll inventory and a lot of other products that could be very complementary to this map that you're showing and also to the presentations. But that can be covered after the presentations.
Sounds good. Thank you. All right. In that case, I'm going to leave the floor to Ashneil, and I'm going to stop sharing my screen. And in the meantime, I'm going to share the links on the chat. Ashneil, the floor is yours.
Thank you. Are you able to view my screen, Paul? Yeah? Yeah.
Yes, we do.
Yes.
All right. Good morning, all. So, as I've introduced, so today I'll be presenting on groundwater and surface water monitoring techniques. So, this will be like the general overview, how we going to monitor the surface water and groundwater, and what are the objectives of monitoring groundwater and surface water, why do we do it, and what are the applications of monitoring groundwater and surface water. So the objectives of monitoring groundwater and surface water is to assess the water quantity. So we want to know what's the head levels in the aquifer. We want to know the flow, and we want to know the flow directions. What is the flow direction of your aquifer? You want to know the recharge, how much water is getting into your underground aquifers and also on your surface waters. And then discharge. Some of the discharge zones for groundwater would be like some lakes or rivers. And then you want to assess the water quality. So in sense of contaminations, if there's a mine site nearby, so you want to know if that mine site is contaminating the water quality or the surface water or the groundwater, and you want to measure the salinity. So salt water intrusion is very common in Pacific Island countries. So you need to measure salinity, and then of course the nutrients and metals. So the metals could be dissolved or the total metals. So there are a lot of physiochemical parameters and a lot of metals that has to be measured. And then by doing the monitoring, what we are doing is to support the management and the decisions of the regulatory compliance. So for example, if there's a mine site and you have to do a compliance report every year to show that you are not contaminating the environment, or you are not contaminating the receiving environment, or the surface water bodies or the groundwater. So these are some of the monitoring objectives, why we have to do groundwater monitoring. Now we know why we are doing groundwater monitoring, and then there's some of the monitoring techniques which I'm going to discuss. So for water level monitoring, we have the piezometers, so that measures the water pressure. And then there are observation wells or the monitoring wells, and then you can use the data loggers to do the water level monitoring. And if you want to know the aquifer properties, and if you want to know what is the hydraulic conductivity or specific storage, specific yield for an aquifer, then we do pumping tests. And some of the pumping tests, some of the examples of pumping tests are using the slug test or the step drawdown. So I'll be discussing more in the next few slides of how we're going to do the slug tests. And then how we also do the groundwater sampling. So there are different techniques of doing groundwater sampling. One is using the paging method, bailers, and then the low flow pumps or the high flow pumps. So I'll be discussing this a bit further. And then of course there are some automatic sensors, for example, the telemetry and the pressure transducers. So as I've mentioned, the slug test. So slug is something like a weight is put on the bore, or a PVC pipe with a known volume is inserted into the bore. As you can see, this is the slug. It goes into the bore, and this is your hydraulic head or the static water level. So as soon as the slugs goes in, the water level rises. So what we do, we time it at every minute, like when the water level stabilizes. So when the water level returns to the static level. So we want to know that time. So based on that time, we can calculate the permeability of the aquifer, what type of material is there, and then your slug is out. And how do we sample water? So using bailers. So bailers are basically the manual samplers. So what it does, you insert this bailer. So this is a simple bailer. It's made up of plastic and it's mostly like 1 meter long. You insert this into the bore and it fills up, and then you pull it out. So what do? We insert this up to the screen and we collect the data, or we collect the water. So this is one of the simplest ways to collect water from bores. However, this is less precise because we do not know if we are taking the water from the screens, or because as soon as we insert the bailer, then we have the stagnant water that is on top of the bore. It gets filled up as well, which we don't want, because we want to know the water from the screen. And then there is this low flow setup. So low flow setup here, as you can see, there are reels. These are the reels. And then we have the black box called the CPU, the control paging unit. And then we have the deepers. So this is the bore. I don't know if you can see correctly, properly. And then we have the compressors loaded. So low flow paging is accurate, and it also gives us high quality results. So there's another high flow paging going on here. As you can see, there are dippers, and then there's this black box, and then compressors. So in low flow, why we do low flow paging? Because we don't want drawdown, or there should be a minimal drawdown. Because what we actually want, we want the water from the screen. We don't want the stagnant water which is on top and then drawing it down. And of course, low flow paging gives high quality sampling results. And there is also high flow paging. What we do, we use higher settings of the CPU or the black box, and it just removes water, like for example 200 liters or 300 liters based on the bore casing and on the volume. So that's high flow paging as well. And then the telemetry. So what we do, we don't go to the site. What we do, we use the telemetry. So we use the satellite or the radio signals to put on this box, and then what it does, it records the groundwater level and also the groundwater pressure and temperature, and then it sends to a cloud form where you can access the data. So, however, to set this up, you need some kind of 4G connections nearby or a Wi-Fi connections. Why do we use this? Because it is automated and you don't have to go out on the field and then manually dip your bores. And then there, what it does, it also shows early warning. So if your groundwater level is decreasing, it can predict as well. And then it saves time for you to go and go out in the field and then do the manual dippings and all. And the data can be linked with your cloud-based models, for example, a digital twin model or optimization model. So this data could be linked to your optimization model. Based on that, you can have different management strategies of how to manage the aquifer and groundwater. Then we have the surface water monitoring technique. So surface water monitoring is basically straightforward. So we measure the flow velocity and the stage discharges. And how do we do it? So we just grab it, the depth integrated, at what depth we want the water level to be collected from a surface water body. And we also do the sediment sampling and the turbidity meters. So they are very good quality probes that do this. And then remote sensing and the drone-based surveys. So we run a drone over your sampling site and we want to know that, for example, the riparian cover and all these things. So we use the drone-based surveys in a surface water monitoring site. So what do we measure from this ground and surface water? So mostly the physiochemical parameters, the temperature, the turbidity, electrical conductivity, of course, the pH, the dissolved oxygen, and all these metals. And we also measure the chloriforms, algae, and macroinvertebrates. And there are different metals as well that we measure based on the site specific. For example, in a mining site where we do or where we process gold, so we use a lot of cyanide. So we have also included cyanide as well in surface water and groundwater. And then the instruments that we use are mostly the multi-parameters. For example, this is a probe which we use for groundwater and surface water. And this is a YSI. So the instruments which I have already discussed, for example, the data loggers and the telemetry system, and then the remote sensing, for example, satellite drones and the LiDAR data. And of course, the GIS and the modeling integration, how we integrate the data from the field into your models, for example, groundwater and surface water models or the flood models. The sampling design, what is the frequency and when should we do it? So we should know when do we need our surface water and groundwater to be monitored. Is it to be continuous or periodic? Is it going to be monthly or 6 monthly? So we need to know that to do a good monitoring network design. And then you also need to know the location of your sampling location, the sampling locations. So we mostly do the upstream and the downstreams and also the receiving environment. The recharge areas where the recharge is coming from, the discharge areas, and then the contamination sites, if there are some tailings dam, so it's going to leak and the water runoff from that, it will go on to the surface water sites and it will contaminate. So we want your bores to be placed just behind your tailings dam as well. So the location also matters when it comes for the sampling. And then the spatial coverage. So do you want it to be site specific or regional? So site specific when there's a mine site. So you want to surround your bores around the mine pit and also the tailings dam. And then of course the data analysis. So data management and analysis. So you want the QA and QC, which is the quality assurance and the quality control procedures. So we do the duplicate samplings. And then we also do the fill blanks. So this measures and this fulfills the QA and QC procedures. The trend analysis, what do we want to show from your data? Is it going to be time series or something else? And where do we want to use this data in? For example, in mode flow models, when we are doing the groundwater models, or the contaminant plumes, which is the MT3DMS. So we use a lot of this data into these models and integrating the climate data and the land data. What are the applications of groundwater and surface water monitoring? So why do we do it and where it is applied? For water supply management, because we want to know how much water is going to be supplied to a processing plant. For example, there's a processing plant and we want to limit the water or the groundwater take from there. So we need the groundwater head values, because if we keep on taking water from the aquifer, what will happen? All the water will deplete. So for that, we want to monitor your surface water and groundwater. And then there is this contamination detection, the contamination from nitrates, the metals. Now there's a new thing as PFAS, and then mining impacts. And then we do this for the regulatory compliance. For example, we want to lodge permits for mine extension. So we need to show them that we are not going to impact the surface water or the groundwater bodies around your mining pit. So we need to do a lot of ground and surface water monitoring, or also on environmental impact assessments, EIAs. So we do that a lot. And for that, we need a lot of monitoring network designs. And also in the research, for aquifer recharge, hydrology and hydrogeology studies, groundwater models, and surface water models, flood models, we use a lot of ground and surface water data to do research. What are the challenges of groundwater and surface water monitoring? Is that the equipments are costly. For example, the probe that I showed you is around somewhat around $20,000. So it's high cost and maintenance as well. And also the accessibility. Sometimes it's very hard to go to a mine pit and then take the water sample from there, because, and also the sites are very remote. It's very hard to go and then do hiking as well. And then some aquifers are very deep, then we do not have the reels or the compressor that can pump the water from a 500 meter aquifer or bore. And then there are data gaps and uncertainties that also occur. Well, yeah, that's all. If you have any questions, I'd be happy to take them.
Thank you very much, Ashnil. Actually, I have one before I will give the floor to everyone. Is what would be your tips and best practices to someone that would like to start monitoring, let's say, for example, a new site of groundwater? Like, what would be your tips and best practices that you would share?
So some of the tip would be like, if you want to start groundwater monitoring, then you need to do your groundwater monitoring network design. You need to know why you want to do it. And so once you know why you want to do it, then based on that, you will place your bores, or you will go out on the field and say, okay, based on these things, the bores should be here, 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 here. And yeah, so
Thank you. Does anybody have some questions for Ashnil? You can actually open your microphone, open your camera. Normally it should be open to everyone. Feel free to ask your questions. And I believe many of us are kind of experimented with hydrogeology, so you can go and ask some technical questions. I'm pretty sure we will have someone to answer it, even if it's not maybe Ashnil, but he's an expert anyway. So feel free to ask.
I have a question.
Sure. Go ahead. Is it Kathy?
Yes.
Go ahead.
So you mentioned in one of your slides using remote sensing to measure the surface area, was it? Can you go back to one of your slides? You mentioned using remote sensing to monitor surface water. So do you use what satellite image do you use, and how do you?
Yeah, I think it's on number 7.
number 7. Is this one?
No,
surface water?
the one before.
Or the telemetry?
No, the next slide.
Surface water?
Yes. So surface
Okay.
water monitoring
Yeah.
techniques using remote sensing and drone based. So which satellite imagery do you use, and
So I
if there
have
are
mostly
specific
done the
bands that
drone.
you use?
Yeah, thank you. So I have mostly done the drone based surveys. So what we do, we go to a
Okay.
site and then we want to find out if mine is affecting this surface water site. So we were doing the riparian cover study. So what we
Okay.
did, we flew our drone 500 meters upstream and then 500 meters downstream, and then it covered everything. So we have mostly used the drone-based surveys. Yeah.
You did not really use a multispectral imagery.
No.
Okay.
Thank you. Nicolas, you have a question?
Thank you, Pearl, and thank you, Ashno. That was a great overview of some of the fundamentals of this kind of work. I was wondering, I'm not sure if you're able to elaborate a bit on your current work, or some of the past work you've done on the mine sites and the projects you've done in environmental monitoring there. My question was, in those projects around the mines, have you had to collect a lot of water quality data um, around, like, surrounding groundwater and surface water ecosystems, like, downstream or connected to the
Yeah.
mine sites? And have you come across a lot of cases of, like, what have been some of the main symptoms of pollution or contamination that you may have detected or not detected, like heavy metals or algal blooms, or what have you found? would be great to just hear some more stories of what you
Yeah. Yep. Thank you.
found for
Yeah.
this
So,
work.
yep. Thank you. So I have mostly done this surface water and groundwater monitoring as well when I was working for consulting firm. So we used to go out like every month, and then we used to sample these surface water and groundwater bores for mostly around 50 mines in Queensland. And what we have found out from the data analysis and from the results that some of the mine sites are affecting the receiving environments. So what do? We have done the reports. We have given it to them, and also these contaminations were mostly from the heavy metals, leaching, and there were some legacy mines as well. For example, show you here. For example, this, you can see this is the blue. So that's a blue. Ah, yeah, from that pit. So that was a uranium mine, and it leaches a lot into the receiving environment. And there's this the tailings or the waste rock dump that what do you call it? Leaches into the groundwater system and into the surface water system. The EC for those areas, the electrical conductivity is around 50,000 microsiemens per centimeter. So that's how the contaminated or the water is contaminated to that extent. So mostly due to the salts that is leaching and also the evaporation. So when a lot of water evaporates, then the salt is there,
Yes.
and then it mixes
Yeah.
with water and increases the EC of your water. So yeah, mostly that. And now I'm working for gold mine, and we are using a lot of cyanides. So we are now monitoring cyanides and how it affects, because cyanide affects your airways and you cannot breathe. So we are doing that as well. And we're also doing the dust monitoring, how it affects human health and all this sort of stuffs.
All right, but so what I actually understand is that if you don't have the opportunity to follow everything, following the salt is actually one of the priority. It's one of the easiest to follow. One of the parameters. Thank you so much, Ashnil. I see the time that is flying, so if you have more questions for Ashnil, the best now is to type them in the chat, and we will be able to answer them by writing. And I'm actually going to leave the floor straight away to Kathy, so she can present about PNG. So I'm going to share my screen so you can actually see. Up. Is it going to work? No, let me see. Up. It's not the one. I'm going to do this. There we go. And then share my screen. All right. Kathy, the floor is yours.
Okay, thank you. Thank you, everyone. Thank you for this opportunity to share the research that I've started, and it's basically on identifying groundwater potential zones using geospatial techniques. It's for a specific location. It's a district in Central Province, in PNG. So moving on, why map groundwater potential zones? Nearly half of Papua New Guinea's population, we still lack access to basic drinking water, and more than 80% do not have access to safely managed sanitation. That's according to UNICEF 2025. Furthermore, Central Province, the location of the study area, experiences extreme levels of drought, extreme levels during the drought season. And so it's important to identify these groundwater water potential zones to support long-term growth and climate resilience, especially in these regions that are prone to droughts. Also, it allows for making water available for everyone in the community and to have this baseline information for policymakers to plan these water resources. And also, like our previous speaker mentioned, it's to prevent an environmental degradation, to identify those um, water sources, to protect them and prevent projects or developments that can affect those regions. And so an example there is a map of the groundwater potential zones for a province in Papua New Guinea, Morava province. And so that is an example of the output from this research. So moving on, what is the aim of this project? Yes, to map out groundwater potential zones, we are using GIS and remote sensing techniques. Firstly, we need to identify those indicators or parameters that influence groundwater occurrence and weighted overlay assessment using ArcGIS through the MCDA and AHP technique. That's the multi-criteria decision approach. And finally, we have to perform validation of these results through ground truthing. And so some of the techniques that our previous speaker, Ashley, mentioned, those are some of those techniques we can use to verify our results. And of course, once we have these ground potential zone maps, it can provide it to those relevant bodies, especially our provincial governments, to manage and plan for sustainable water resource management. So the problem statement. Many villages in the Riga district in Central Province, like mentioned earlier, will lack this infrastructure for water and sanitation. Usually it's the women and children that walk long distances to fetch this water. And during the seasonal droughts, these creeks dry up. And so they have to walk further inland. And these women and children that go out to collect water are at risk of harassment. And these communities are also vulnerable to waterborne illnesses. Furthermore, there is no proper water and sanitation infrastructure in the many schools within the community. So these are all hindrances to the socio-economic development. So groundwater potential zone mapping, it provides the baseline for better water supply planning and development within the district. So that's why we decided to carry out this research. Study location is approximately 40 miles from the capital. The climate is hot and humid, tropical year-round. The annual rainfall is around 2,500 mils, and with a population of about 70,000. And we have all these infrastructures. So the framework, the conceptual framework, it involves integrating the various indicators as in the form of thematic layers. And these are derived from remote sensing data and also the PNG RIS. The PNG RIS is a GIS system containing an inventory of natural resources and physical data for Papua New Guinea. It was first developed in 1981 and updated in 2008. Currently, they are improving the soil and land information. And so that is the base data that I will be incorporating in this project, along with the remote sensing data and digital elevation models. So the multi-criteria decision approach will use the AHP techniques. That is where we assign weights to the different parameters based on their influence on groundwater occurrences. So usually we'll use the pairwise cooperation matrix, where we can consult experts in hydrogeology or through research to compare each of those parameters or thematic layers against every layer based on its importance in influencing groundwater potential. So we will use a numerical scale, set the scale from 1 to 9, where we have 1 meaning the equal importance and 9 extreme importance. So if you see in the table there, that is an example for that previous study, the first map, the map from the first slide. So you will see that we have the different parameters where geomorphology has a higher weightage than, say, land use and land cover or vegetation. So let's see why in the next slide. So this geological lithology landforms rainfall will be obtained from the PNG-RIS data. And the lineaments, drainage, and slope will be derived from the digital elevation model. This is at a scale or spatial resolution of 30 meters. The PNG datasets, they are at a scale of 1:500,000. So the geology or lithology parameter, we're looking at those highly permeable formations like sandstone, trying to see if the study area has these characteristics of sandstone or fractured basalt and unconsolidated sediments, because they generally indicate higher groundwater potential compared to impermeable rocks like granite or shale. So we will overlay the PNG's lithology map over the study area, which is the Rico district, and to see which of these characteristics are within the district. Moving on to the landforms, we are looking at the landforms like floodplains or buried river channels or valleys with higher groundwater potential. This is due to the accumulation of permeable sediments and proximity to surface bodies. Conversely, elevated areas of steep slope will tend to have lower groundwater potential due to the rapid runoff and less infiltration. For lineament structures, we're looking at faults and fractures. So they act as conduits for groundwater movement and storage, especially in hard rock terrains where primary porosity is low. Another indicator would be the drainage density. So areas with low drainage density will typically indicate higher infiltration and therefore groundwater recharge. Slope, land use, rainfall is the primary source for recharge. Soil types. So soils with higher permeability, such, for example, sandy or loamy soils, allow for greater water infiltration and thus contribute to higher groundwater. And so those are the parameters that will be modeled in ArcGIS, and the data sets will be obtained from PNG-RIS, the satellite imagery from Landsat, and the digital elevation model, also from the USGS Ed Explorer. These parameters will be generated and thematic layers will be created. And using the MCDA and AHP approach, weights and ranks will be assigned according to each of their influence to groundwater potential zones. The weighted overlay analysis tool in ArcGIS will be used to perform this analysis, and finally the output of the groundwater potential zone. The techniques that was mentioned by Ashneil on monitoring of groundwater and surface water, those are some of the techniques that I intend to use to validate the final groundwater potential zone map. So moving on to the next slide. So the expected outcomes from this project. The groundwater potential zone map for Rigo District will provide that baseline data for decision making and improved water resource planning. The challenges that we may face for this project will be the data availability and quality. It's expensive to use some of this equipment to drill or to verify our groundwater potential zone, but we'll use whatever available data, especially from the water departments we have in PNG, like the water PNG, they have data, but the challenge would be them having that data shared with us. So those are some of the challenges we have, data sharing. But otherwise, this using GIS and remote sensing techniques and the baseline data that we have, the PNG RIS data, we should be able to come up with this groundwater potential zone map. So we feel that this is a very cost-effective approach to identify and manage the vital water resources we have in Papua New Guinea. And this conceptual framework is a systematic methodology that can be applied in other communities in the Pacific to address water scarcity and promote sustainable development, and of course, climate resilience to improve the livelihoods of our communities. So that's it. Thank you. Do we have any questions?
Thank you very much, Kathy, for all this. Actually, I have one, and it's going to be the same one as Ashneil. Is what would be your tips and best practices to somebody that would want to do exactly what you did to try to assess the potential zone? Any tips or best practices?
Yes, firstly is to reach out to those experts in the field of groundwater and to identify the bodies that govern or have those policies for managing water in the country. But for rural areas, it is quite challenging, but do approach those bodies. Do approach those bodies that are responsible for managing water in your nation. Yeah.
Thank you. I see that Nick and Anesh have raised their hands, so I don't know who was first. Anesh, I guess.
Go first, Anesh.
Hi, Kathy. Nice presentation. I have actually 3 questions. The first one is 30-meter resolution the best you have for the DEM? And the second question is, have you thought about using AI to see, how it's different from your groundwater potentiality map? Because the main challenge is using the IHP and giving the score, because I have tried it, or I've done it during my thesis. And the third question was, like, PNG, do they have a groundwater monitoring network? Because you also mentioned that you're gonna do a validation of your map once it's completed using the groundwater data. So like PNG, do they have monitoring network currently for the main island? Thank you.
Okay, thank you. Thank you, Anesh. Firstly, for 30-meter DEM. Well, I'll try 30-meter DEM, but I also know that there's a 12.5 DEM that I can use. But otherwise, high resolution imagery it's quite expensive. So I'll try using 30-meter because the other data sets or parameters that I have are also in that resolution. So I have to use one that is standard. But if I can bring it down to 12.5, I will also try that and see the output. For monitoring, there is a site. I can put up the link there, but it's called m.water. So there are some information on the water points all over PNG. These are not only for groundwater, but they are for wells and tanks. I think it's for the UNICEF WASH monitoring program. So that is one site. Another, I could get um, points for the wells that have been dug by the Mineral Resources Authority PNG. They have some data. Also, the water PNG, they have locations for wells that they have dug. So maybe I can use that to verify. Otherwise, to go out to the field, and the region, the district is quite big. If I were to go out and do field verifications, I would only go to the villages that are easy to access and identify those wells that they have done to verify the results. I think I answered two questions. I missed the other question.
Okay, so the third question was using AI, just to compare. But before that, so we are doing something similar for Fiji for the Vitilevu. We are
Okay.
trying to make a groundwater potentiality map, and to validate that,
Okay.
we also want to use some geophysics data. Maybe
Okay.
it's
I
one
see.
of the things you can try, because I'm pretty sure there's a lot of geophysics that was done or
Yes.
still being done in PNG, and probably you can use the data. You might have to reprocess it for the groundwater, but it can be very useful tool. Yeah, but the third
Thank
question
you very
was
much.
use of AI.
I have not used that. I will check it out.
Unless you will have
Yeah.
to present next
Thank
year.
you.
Oh, you did. So the other islands can actually do it too.
Actually,
Thank you.
Vono, she's she's in this meeting as well. She will be presenting.
Perfect. Nicholas?
Yes, thank you. Yeah, thank you, True, Kathy, for the presentation. And just to clarify, are you with Unitech in Leh, or where are you based at the moment?
Yes.
Okay,
Unitech
great,
here.
very good. I think that Unitech Leh also were some of the champions in the hackathon for OGS in 2022.
Yes.
Mm-mm.
In New Caledonia. Yes.
Mm.
Those
Uh,
Dr. Sekak and Oceania.
yes, no, really good work from Unitech. I had a basic question, and you may have covered it a bit, but my internet might have cut out a bit. When you did your catchment delineation, just that map you had for your catchment, are you using
No,
pardon?
the boundary that I have is only for the district, the political boundary.
Oh,
I
okay, it's
did
just a political
not
boundary.
use the catchment. Yes, but the catchment, there are two catchments within the district. One is the Camp Welsh catchment. It's pretty big. It
Mm-hmm.
goes past the district boundary, but there's another one as well, and there are also smaller catchments. So I was thinking uh, whether to use to do the groundwater potential zone mapping within a catchment or just have the district boundary as the,
Mm.
yeah.
Well, yeah, I think that's a good question. I think I don't think I think that's something worth thinking about a bit. And my opinion, my humble opinion is that it is probably good to use the catchment boundary, but also to have a
Okay.
district level output. But yeah, I guess my question was going to be, what do you guys at Unitech usually use to do your catchment boundary delineation? Are you using open source or Esri, or what are you using for your catchment boundaries?
I use the digital elevation model
Mm-hmm.
to come up with the catchment.
So which software are you using though?
ArcGIS,
Oh, ArcGIS.
hydrology
Okay.
tools in ArcGIS.
Okay.
Yes.
No worries, that answers my
Yes.
question because we use QGIS, but a lot of the libraries sometimes become outdated or deprecated, so it becomes hard. So if you've got Arc, I guess that
Okay.
that helps. Okay, thank you very much for the great presentation.
Thank you.
Thank you, Kathy, for the answers. Do we have another question? If not, it's almost time, so I'm going to share my screen again. I actually had prepared a quick interaction, but as we are past on time, I will just share you the link. So if you want to answer, I wanted to let you know what is next in our scheduled calendar. So we have been talking about hydrogeology today, and actually, just so you know, on September 25, we will try something new for a community of Oceania Geospatial. We will be having an online training with the Dr. Fatima Castelli and Dr. Chris Leong. So we will, it's on Modflow, the software for open source. It's an open source groundwater modeling and monitoring software. So if you're interested in this, then you will be able to register for this online training. In October, we will have a technical webinar like today around wastewater and reuse. And then October and November, as you can see, we have many global and international events that are already planned, and especially the Oceania Geospatial Symposium. I will just give you a few words after about that. But just so you know, yeah, our next event are here in October, and then we will have one last one in December. As always, stay tuned on our LinkedIn just to make sure what's happening and have the right links to connect. And actually, I had Nicolas was talking about it, but we had the Oceania Geospatial Symposium in 2022 in New Caledonia. And I have I'm very happy to let you know that we are on track to organize the next one at the end of the year, in November, 24th to 28th of November in Suva, Fiji. So it's time for you to save the date, and this event will be organized also with the Pacific GIS and Remote Sensing Council. And so I wanted to let you know so you can actually save the dates in your calendar. What else? Yes, well, thank you all for attending. I think we are right on time. And so I don't know if you have any more questions before we finish. I'm going to share the few links right now in the chat before I stop everything. Thank you, Kathy, for presenting. Thank you, Ashneil. He's already gone because he had another meeting, but thank you to our great speakers. It's really great, and I'm very happy to actually have a lady presenting with me to change a bit. Oh, I forgot. Yes. Do you think you can put up your camera? We will take a picture all together because we're all coming from so many countries of the Pacific. I would be glad to see all your faces before we go, please. And maybe we can actually take a picture. Right, I'm waiting for a few more. Anesh, Nazir, maybe? Jutiti? No? That's okay. I'll take the picture now. Up. That's okay. All right. Is everybody smiling? 1, 2, 3. All right. I think you're in. Up. There it goes. I have it. And I forgot to send you the link for the registration now that I think of it. So let me see. Up. I'm just going to give it to you right now. Up. I gotta stop sharing this. Get here. Copy the link. Paste. Copy the link and paste it. I forgot to edit earlier. Have it ready. There it is. Oh, yeah, it's here actually. Links to register. Yes, you had it. Sorry, I didn't see it. Thank you, everyone. I hope to see you next month for the ModFlow training. And you got the link now if you want to register, and you will have the emails with all the information. Thank you. Merci beaucoup.
Thank you. Merci beaucoup.
See you
Bye.
soon.